All right, recording is rolling. Welcome to Tuesday, August 22nd. We're gonna run a Kahoot here pretty quick here. So you guys walked in, you guys have your laptops open. A lot of you guys already logged on. That's really awesome. Show you guys what we're doing, and then we'll run back there. So yesterday we went through some trigonometry type stuff, right? And I've got two main posters for that. I got this one has Pythagorean theorem and the area of a triangle on it, and this one with sine, cosine, and tangent. And then I rearranged this a little bit to put them in like a physics context. How you see these like 90% of the time in physics, and 90% of the time it works like this. Oh, a right triangle is really some vector, right? Maybe it's a velocity vector, maybe it's force vector, some kind of vector, lots of vector quantities, and you want to split that into components. Say, well, if this one's going like up and to the right, well, how much up and how much to the right? And you can quantify that if you know also this angle, right? So you'll see it like that. I showed you guys how to extract an angle if you know a bunch of side information, right? There's ways to it involves an inverse trig. In this case, I put the inverse tangent on the poster, but if it is inverse tan, then you're just laying off the two legs because tangent has something to do with the two legs specifically. Right? So remember, you can take sine, cosine, or tangent of an angle, and it will spit out a ratio. You can take an inverse trig of a ratio, it'll spit out an angle. Okay, that's how you extract an angle. Okay. Yesterday, you guys got a page that looks like this. On one side has 5 triangles on a table, and the other side has these 10 trigonometry puzzles. We got started on this yesterday, so just to get you guys back in here, I said star any 3 of these rows, like any 3 triangles, and just ignore the other 2. I walked you guys through one of them. I walked you guys through the Schrodinger triangle. I gave you guys, and this involves, this is the science portion of this. So I had you guys take some measurements with your protractor and your ruler, get some calculations, and there are different calculations you can do for each side, depending on what information you start out with. But ideally, your calculation should land pretty close to your empirical measurement. Right? That's the idea. That's the science side. On this other side, I will get you guys started with this after the Kahoot. I'll do a couple of examples. I told you guys, right, due Friday, 8:25 on this. Right, you guys got that? So after the Kahoot, I'll do a couple of those examples, and then I'll give you guys the rest of the class, which will probably be about maybe 10, 15 minutes to work on those. And I've had some students already finish those by the end of the class today. You guys see this great Trey? If you keep a good pace and you finish that whole page today, you can pop in there and you're good to go. Otherwise, do Friday. Oh, look at you guys go. You guys are all logged on. All right. You guys got your calculators ready? Ready? All right, we're going to gunsling this thing because short clock time. Right, triangles. Yeah. These are all right triangles. They're all right triangles. Solve for Um, oh, one winner. Yeah. I know that wasn't enough time, but I guess that's part of the fun of this one, right? Right. So you got your calculator out. If you really know what you're doing, you can bam, bam, bam. Right. I told you guys take to heart, especially here. Let me see. Pull this up on the poster. Right, guys. These 2 boxes, especially. Uh, the opposite of the angle is hypotenuse times sine theta, and the adjacent leg is the hypotenuse times cosine of that angle. Right. Know these by heart the way you know the alphabet, because all over the place. This is like the first step of so many problems. I think I even got a poster here that has the cannon blast and cannonball at some angle. And that's like the first step, right? And then it goes on from there. Right. So yeah, I know that's real short time there. Right, this is what you guys had. You have a right triangle. Here's the right angle. It had hypotenuse magnitude 50, and this was at an angle of 65 degrees from the horizontal. You could say it like that, right? Right, now, I've actually modified a little bit how I drew this, which looks a little bit different than it showed on the screen. On the screen on the Kahoot, it was just a triangle, right? But I'm putting this in a physics context. I want to make this a vector. So maybe it's 50 something. How about newtons? Suppose that's like a pushing force. Suppose I'm like pushing 50 newtons, right? 50 Newton pushing force, right? And I'm pushing it up and to the right. And I want to quantify, well, how much up and how much to the right, right? Because that could be a good first step for a lot of reasons, right? Okay. So how can I get that? Well, actually, the answer is exactly this one right here, right? Because I told you this angle here, right? Oh, did you guys see how the adjacent leg that you're solving for, x? I mean, it is adjacent to the reference angle. So adjacent has something to do with the cosine. Take your hypotenuse, multiply by cosine of the angle. Is that something else I meant to point out? You guys see how the two legs of the triangle actually dashed like that? You guys see that? Right. Now this is an important thing, especially for AP. Right. Especially for AP. If I made those solid, then let's say I have some object here, and I draw like that vector and that vector and that vector. Right. If I draw these all as solid, then I'm like double counting the vectors. I'm saying, well, there's this push and there's also this push and also this push. No. Right. I'm trying to re-represent this vector in terms of its components. That's why I dashed them. On the AP exam, if you get enough RQ and you have to like actually draw maybe exactly that right there, right? Make sure you either don't draw the components at all, or if you do draw the components, make sure you dash them, because if you make them solid, then AP will count off of that. They won't actually give you credit, right? It's a little stickler thing there. All right, so you guys know this is going to be your 50, well, I'll call it 50 newtons. How about that? 50 newtons. Right, I just made up a unit for that. Right, times what sine or cosine of this angle? Cosine. Right. Again, take that to heart. Know that like you know the alphabet. Right, let's try this out. So 50 cosine 65 degrees. Okay. I'm looking at 21.1 is the magnitude, and newtons is the unit. Try to avoid having naked numbers in this class. So every number should have a unit attached to it, with a couple exceptions. Okay, guys got that? All right. Flip back over here. Oh, short time. Let's see who got the points on that. Oh, Steven got the points. Steven. Solve for y. Hey, it's the same triangle. Oh, look at all those winners. All right, you guys are catching on. Oh, yeah. Oh, yeah. All right. You guys caught on pretty quick. Right, so if you want this leg that's adjacent to the angle, multiply that hypotenuse times cosine. If you want the leg that's opposite of the angle, let's say it's not touching it at all, well, it's just this guy right here. Right? So let's do that. So I'm going to start off with my hypotenuse of the triangle is 50. Okay, going newtons. Right? We want the components going, well, okay, it's opposite of the given angle. So times sine of 65 degrees. All right, try this out. 50 sine 65. All right, a lot of you guys got 45.3 is the magnitude. Newton is the unit. There you go. There you go. Oh, yeah, go ahead. Did you do 50 sine 65? Is your calculator in degrees and not radians? Is there like a mode button on the calculator? Let me see if I put my calculator in radians, what I get. Degrees, switch to radian, see what that is. Oh, that's exactly what it is. Your calculator's in radians. So find some kind of mode. Every calculator is different. So, okay, all right. Yeah, all right. You know what, let's do a little extension activity on this one. I want to just for at least one triangle. Got a good opportunity here. Who can tell me, what is this little skinny angle up here? What's that? Or 25 degrees? A few of you guys are telling me 25 degrees. Yeah, right. How'd you know it's 25 degrees? There you go. There you go. Right. All three angles and a flat triangle up to 180 degrees. 90 of those degrees are occupied by this right angle. The two acute angles in a right triangle always add up to 90 themselves. 90 minus 65. Okay. Hey, could I do this? Could I say y is equal to 50 newtons times cosine of 25 degrees? Is that the same thing? Is that the same thing? Adjacent to 25 degrees? Let's find out. 50 cosine 25. Oh, look at that. It's the same thing. It's the same thing. You guys see it? All right, so you can navigate your way around the triangle. All right, you guys ready for next triangle? Well, almost. Let's see how we're doing on the points. We got Harmon, Sarah, Sohan, Catherine P, and Steven. Yeah. Solve for H. All right, all right. What method did you guys use to solve for H? All right, I'm here in Pythagorean theorem. I'm here in a squared plus b squared c squared. There you go. That's two sides of the same coin. So yeah, something looks like, okay, there's a right angle right here. I tried to make this look like a something to do with vectors, right? Right. Oh, suppose here, let's attach a story to this. Suppose there's a river that's flowing west to east. You guys see the river flowing west to east at like 10 meters per second? You guys see that river current going 10 meters per second? I'm gonna have a guy on a boat, and he's aiming straight north, and he can paddle at 11 meters per second. He's a quick little feller, and he's going across. Hey, do you think some guy standing out here by this tree sees the guy not only going across how he's paddling, but also being swept down river at the same time, going along maybe this diagonal path? Right? Right. But what's the total speed? Like, suppose this guy has a radar gun, and he says, like, what's the total speed? He points a radar gun at this guy in the boat, right? That's also what you guys just found. Right? We call it H, maybe H for hypotenuse. You said H squared is 10 meters per second, big squared plus 11 meters per second, big squared. Oh, I should tell you guys in to key you guys into this. See how I put the unit like beneath the number? That's not a conventional textbook thing. That's just a Griffin thing. I do that just to maybe just focus on the numbers is easy. But all these numbers have the units attached to them. But if I don't do that, then it's like, okay, we got numbers and letters all in the same lines. Yeah. Right. Or you could have just jumped straight to this step. H is the square root of 10 meters per second squared plus 11 meters per second being squared. Notice my square root bar extends over that entire inside expression. Square root 10 squared plus 11 squared. Right. And yeah, you guys are saying 14.866, let's call it 14.9. And then if it had vector units like meters per second, we like the story of the guy in the boat. Yeah, there you go. Okay, you guys good there? Oh, I should tell you guys, there's 10 Kahoot questions, there's 5 triangles. Every triangle has a pair of questions. That's the first question. That's why I take a wild guess what the next question is. Ooh, what do you guys think on that? We got Sydney, Ian, Carmen, Catherine P, Steven. Solve for theta. Ho, ho, ho. Where'd you guys go? Unless you guys got that. So, oh, I forgot to share my screen on that. Okay. Well, sorry, if you watch this video at home, it's the same triangle, you just solve for theta. Okay, so you guys got that. And most of you guys got that. How did you solve for theta? You have to apply something to do with an inverse trig, right? You guys remember this? Right? You guys remember here, if you do any trig, sine, cosine, or tangent of an angle, how do you normally apply this? It'll spit you out some ratio. Right? But what if you're loaded up with lots of side information? Like we know all 3 sides of this triangle. Say just like 14.9. Right? Then you can do the inverse trig of a ratio. That'll spit you out the angle. Right? That's exactly what's going on here. Let's go. Theta is, suppose you want to play off the 2 legs. Now, if you're playing off the 2 legs, does that have something to do with sine, cosine, or tangent? Which one?
Tangent.
Yeah, tangent. Yeah, the 2 legs is always tangent, right? Right. Sine and cosine, well, you got the hypotenuse in the mix, but tangent only deals with the 2 legs. Right, so we're going to do inverse tan, ratio of the legs. That's it. Inverse tan, also called arctan. Right? Let me go 11 on 10. How about that? Right? The units cancel out, so same unit. Right? Inverse tan, 11 on 10. The number is 47.7. The unit is degrees. Boom, there you go. Okay. You guys get there? All right. Okay. Got that in your notes. In the notes. Oh, yeah. All right, back over Kahoot. Ooh, big leader shuffle. We got Carmen, Melissa, Sydney, Steven, and Catherine P taking top spot. Oh, and some of you guys are on fire. Oh, yeah. That's always a good sign. Solve for Y. All right. So this guy's got that too. Can't believe I forgot this, but here, I know you guys are one of my AP classes. You guys are probably on. Anyway, all right. So if you don't have a notebook, here, you guys see a stack of paper right here. Okay. That's if you forgot to bring your notebook today, but again, you guys are AP, so you guys are probably all right. So let's switch over here. So I got this triangle drawn out. It's what you're given. Well, it turned into like a vector type problem, right? Suppose someone's pushing up to the right. You would say like, how much up and how much to the right, right? Okay. Let's throw a unit on here, make it look more physicsy, right? Let's say newtons. Let's do like a push example, right? Okay. So, let's see. You know some angles going on. You could probably figure out this one real fast if you want to. You know all the angle stuff, right? You know one of the legs and you want the other leg. Is that immediately going to fall into a sine, cosine, or tangent category? Tangent, right? Right. There are some backdoor ways to solve it too. Right? You don't have to do that, but that's the fastest way to solve it because that involves two legs. Right? Tangent's always the two legs, right? Like skipping over the hypotenuse. So let's set up a tangent. I can say that tangent of this 28-degree reference angle is, let's see, opposite over adjacent, right? Opposite. So it'd be like y on 99 newtons, right? Oh, well, now we're just one algebra step away from getting y. Just cross multiply this 99 newton, like that. So I'm going to get y is equal to 99 newtons times tangent of 28 degrees. Can you do that? Okay. Let's try it out. 52.6 is the number. I went with newtons, so let's go with newtons. It was, all right. There was just swapped up the, anyway, that was good. That was good. Guys good? Ooh, you guys have a pretty good prediction what the next question is going to be? If you're taking notes, might help you out a little bit. Peer into the future. So we're doing on the leaderboard. Ooh, got Melissa, Sydney, Ian, Steven, and Catherine P. Oh, 4-point lead. Look at that. Ooh, it's a race. Solve for H. All right, we got some winners. Right? Now at this point, remember same triangle as last time, so I'm gonna pick up from these notes. Solve for H. Right? At this point, you have so much information about the triangle. Right? You got this angle, this angle. You probably grab this one real fast if you wanted to. You got this side. We solved for this side already. Right? There are multiple ways you could get to the answer. What's one way that you guys got to the answer? Yeah, what you guys see?
99 over sine 28.
Ooh, okay. Something to do with okay, so something to do with the 99 and bring in the cosine. It looks like. Here, yeah, I have to do it from scratch. Yeah, you're right. You're right. I know you got this. I have to back up because yeah, I got to help myself out a little bit. Like I said, from scratch, you need to go cosine of 28 degrees. You're right. It is that. Would in fact be this adjacent leg divided by this hypotenuse. Yeah, that's one way to do it. Now, if you start from that, then I have to do a little double switchery, right? I have to cross multiply the h, and at the same time divide this cosine down. So I'm going to get h is 99 newtons divided by cosine of 28 degrees. There you go. That will definitely work. Okay. So let's check that out. 99 on cosine 28 is, I'm getting 112.1. And then, okay, I went with newtons, so let's go with newtons. All right, you guys do that? Okay, we're good. What's another way you also could have gotten h? If you know the two sides, can you Pythagorean theorem? Here's the answer, last one. Okay, let's try out Pythagorean theorem. I'll just show on my calculator screen. So square root of a squared plus b squared should give you square root of 99 squared plus 52.6 squared. Oh yeah, look at that. It's still 112.1. Okay, still same thing. Okay, that's good. So back over here. Okay. Oh, forewarning. The next triangle is going to also be a right triangle. It's just going to change orientation a little bit. Let's be ready to feel that. Got Ian, Addie, Melissa, Catherine P, Steven. Okay. So look for like a sideways triangle, but it's still going to be a right triangle. But there's a reason I'm giving it to you like this. Still a right triangle. Oh, all right, got some winners going on right there. Let's check this out. All right. Now, why did I switch orientation? Because so far I've only shown you this classic like first quadrant type triangle where the right angle's down here, right? Okay. So this guy's all upside down and backward. Oh, the reason is, so if you're sitting in class, do you guys see a poster in the back that says block and equilibrium on an incline? It's all by itself up there, kind of in the middle, block and equilibrium on an incline. Okay. So if I put an object on a surface and I tilt that surface, right, then this is a really classic category of physics problems. Okay? Then there's a bunch of force vectors going on. There's a weight pulling down. There's like a normal force pushing up, like to the left. This is all a few weeks from now. I'll key you guys in. There's probably a friction force going on. Okay? And to make sense of it, you have to break it into components. And you'll see triangles that are oriented exactly this way. Okay, so just look for this in the future. You'll do them pretty good at that poster. Might see how this is going to work. Okay? So in fact, I'll use that example. And if I do, then this would be like possibly a weight in newtons. And then maybe that weight is partially pushing into the surface and partially pulling along the surface. So some version of that. Okay. Actually, here. Experiment. I'm going to show this to you guys. I'm going to show this to you guys exactly what I'm talking about. Okay. So suppose I got a surface, because I didn't explain that maybe the best I could. Okay. Suppose I got a weight on that surface. Okay. And that weight, well, weight is a force, it's a gravity force. I'm going to label that mg, like as variables multiply the mass of the object times the gravity field of the planet is like a downward force, like a weight. Okay? But this is on an incline. So to make sense of this, like the first step you're going to do, again, this is like a few weeks from now, a topic we're going to cover, but just cue you guys in, set you guys up, is you're going to introduce a coordinate system that runs parallel and perpendicular to that surface. So I got a new axis system. And now this is going to have some other forces on it. It has like a support force from the surface. That's called a normal force. I'll call it F sub n. Like normal means perpendicular, like support force from the surface. And if it's locked in place or sliding at constant velocity, then there's a friction force that might look something like that. Right? So there's those three forces. And two of those forces are aligned to that new coordinate system I made, but the weight actually is not. So you have to break it into components. Change ink color, I like to do. Let's break out the pink ink. Okay. So that weight, in terms of this rotated coordinate system, is partially pushing into the surface and partly trying to make it slide along the surface. You guys see that? And look what we have here. We have that right triangle that's oriented exactly like that question. Like I said. All right. So if you want x, see x is one of the legs. You have a reference angle. You have the hypotenuse. So x must be what times what?
I gotta ask for y.
For, oh.
On the Kahoot, didn't it ask
Did,
for y?
did it ask for y up here?
Did it? No,
I think, here, let's go ahead and do this one. We'll switch over and see. Okay.
Yeah.
All right, so 40 newtons times what? Sine or cosine of 27 degrees?
Sine.
You're right, it is sine of 27 degrees because this leg is opposite of the 27-degree angle. Notice it's not touching the 27-degree angle. Opposite sine. Okay. Let's try it. Let's find out. 40 sine 27. All right, looking at 18.1596. Let's call it 18.2, and then it had a unit like Newton. It could be like that. Okay. Okay. 18.2. Okay. You guys get that? Okay. Right. Switch over. That was dead. We got Eli, Melissa, Catherine P, Addie, Steven. Oh, what do you guys think this question's going to be? Oh, look at there. I hope everybody got this. Oh yeah, look at you guys go. Oh yeah, that's about right. So if the leg opposite of the 27-degree angle was hypotenuse times sine of the angle, then the leg adjacent to the reference angle is what times what? 40 newtons times cosine of 27 degrees. There you go. Yeah. So, and you calculate, actually, if you have this model calculator, right, all you have to do is scroll up, scroll over, and where there used to be a sine, just pop in a cosine. Take care of that. 35.6 is the number. Newtons might be the unit. There you go. Right. So to pull us back to an example of like putting a weight on an inclined surface, which I look like that from the side, I could say that if this weight weighed 40 newtons, pretty heavy guy, okay, then 18 of those newtons is trying to make it slide along the surface, like slide down, and about 35 point something of those newtons is like actually pushing into the surface. Like if I had like a surface that got closer and closer to a wall, it's like almost vertical. I bet this would be getting less and less. Right? Like not the full weight would be pushing into it. So that's future stuff though. All right, you guys ready for the last triangle? All right, this pair of questions about to pop up here. That's how we're doing on points. Ooh, man, this is an exciting race. Got all these leaders shuffling around. Got Catherine, Ade, Eli, Melissa, Steven. Solve for X. All right, you guys are on. You guys are on. You guys probably caught this is the same category questions we were just looking at. Right? So you guys went what times what? Oh, let's make this let's stick to meters. No, let's go meters. How about meters? Let's get crazy. Meters. Right. So how many meters is X? What times what? 300 meters. There you go. Sine 40 degrees. Bam. 300 sine 40 degrees. 192.8, and that would be meters if I did went with meters. Okay. You guys do that? All right. All good? I wonder what the last question is going to be. I hope everybody's going to get it right, though. Oh, yeah. Okay, I got it. So green pass back there. All right, Melissa taking top spot, and it's the last question for the win. For the win. Solve for Y. Let's get 100% on this. Oh, pretty close, pretty close. All right, but very good. All right, so let's go over solution with that and find out who won the Kahoot. Right. So if X was 300 times sine of 40 degrees, you think Y is 300 times cosine of 40 degrees? You could do that. All right, let's check this out. 300 cosine 40 degrees. Okay. Know this by heart. 229, that process. Right? That hypotenuse times sine or cosine of some angle is going to give you the two legs. Okay? Because that you're going to see all over in this class. Week after week after week, you'll see it start so many problems. Hey, what's this angle down here? Is that 50 degrees? Could I have done 300 meters times sine of 50 degrees? Is that good? 300 sine 50 degrees. It's the same thing. Could I have done 300 meters squared minus 192.8 meters squared and then taken the square root? Some kind of Pythagorean theorem. Okay. So like, once you get enough information, now there's like multiple ways to finish that off. All right, let's check out the podium. To the podium with the bronze. After P. With the silver. Eli. And the gold. Melissa. Next up, we got Eddie and Carmen. Winners up. You guys did great. You guys got some new notes. And the world is still spinning. So let's look at that page that's due Friday. All right, you guys remember this one right here? Okay, so remind you guys, yesterday I took you guys through one of these triangles. I said star any three and just ignore the other two. Okay, can you guys do 3 of 5 triangles? Okay, so you guys are measuring a couple of angles on each one, alpha and beta. You guys are using your ruler to measure the 3 sides. That's the science part of this, right? The empirical measurements. Okay, then there's some calculations. Do the sine, cosine, and like backdoor Pythagorean theorem methods of also solving for those sides align with your measurements. Okay, they should land pretty close. And I took you guys through Schrodinger yesterday. Okay, so pick another couple triangles. You look on the back side of this page. There's 10 puzzles related to trigonometry. I'm going to pick number 3 and number 7 and do those with you guys, and then send you guys off from there. I'll walk around the room till the end of class, answer any questions you guys have. So number three, let's see. You know what's a right triangle? These are all right triangles. Okay? I gave you one of the acute angles, and I gave you one of the legs of the triangle. All right. So let's start with this. How am I going to get beta? What is my answer to beta? If alpha is 40 degrees, what is beta? 50 degrees. Right? And how do you know it's 50 degrees? Yeah, 90 minus 40. Right. So alpha and beta should add up to 90 degrees. Right? That was a very math approach, like textbook math. So just go ahead and stick to textbook math. 90 minus 40. Boom. Done. Right. I didn't actually tell you the hypotenuse. I told you one of the legs. Suppose you want the other leg. Let's get leg y. You have x, you want y. You have one leg, you want the other leg. Guys, if you have one leg, you want the other leg. Does that have something to do with sine, cosine, or tangent? Tangent, exactly. Yeah, tangent's something to do with the 2 legs. Right? I just picked that one. That's what we're going to do, but let's go do it. So I can say tangent of, let's go 40 degrees at alpha value. Tangent of 40 degrees. Set up that ratio. It'd be opposite over adjacent. That's like y over x. That's like y that we're solving for divided by x, which was given. And on my paper says 108 newtons. Just so everybody's okay with what's going on. There's like 10 different versions of this paper floating around. So your numbers might look different than my numbers, but use the same process. You guys get the idea, right? Okay. Be true throughout the year. And so all you have to do now to solve for y is just one algebra step. Just cross multiply. It's 108 newtons. So y is now equal to 108 newtons times tangent of 40 degrees. Figure that out. 108 and 40. That is 90.6, I'll round to. I call it newtons. There you go. Write that in right here. 0.6 newtons. I can believe that, because if this alpha angle is, less than 45 degrees, then I know my y has to be less than my x, and that's exactly what's showing up. Yeah, that looks about right. Finally, z. All right. There's probably multiple ways you could solve for z. What's one way you could solve for z? Okay, here's something about a cosine. Yeah, let's do it. Let's do it. I have to go back and solve it from scratch again. So just for my Griffin brain here, let's go. Cosine of 40 degrees is, what would that be? X divided by z. But we have x, right? X was 108 newtons. Let me rewrite that. Cosine of 40 degrees is 108 newtons divided by z. Okay, now we're going to do like 2 algebra steps and together, right? And cross multiply the z. Same time, we're going to take this cosine of 40 degrees and divide that down. So z, do a double switch right there. 108 newtons divided by cosine of 40 degrees. Okay. Should be a fantastic way to get this. 108 over cosine 40 degrees. I'm looking at 141, it rounds to newtons. 141 newtons, right? If you wanted to do Pythagorean theorem, you could have done that. Let me do that real fast. You could say z is equal to the square root of 108 newtons squared plus 90.6 newtons being squared. So square root of all that, extend my square root bar over the entire inside expression. Root 108 squared plus 90.6 squared. I mean, it's the same answer, right? So no matter how you do it. Okay. You guys good there? Okay. Ready for number 7? right, number 7. Ooh, I gave you the 2 legs, and that's it. Besides the fact, of course, you know it's a right triangle with 2 legs on it. How many of you guys can look at those 2 legs and immediately know, without even writing anything, what z has to be? What do you think, Steve?
It's 5.
It's 5? How'd you know it was 5?
3, 4, 5, 6.
That is a 3, 4, 5 right triangle. Yeah. I think I made the same proportion on everybody's, regardless of what version of this paper you have. Like you might have 60 here and 80 here. Guys, if your 2 legs are like 60 and 80, what's your hypotenuse? 100, right? Doesn't 60, 80, 100 reduce to 3, 4, 5 ratio? It's the same ratio, right? Here, let me at least write this down, right? So z would be the square root of 3 squared plus 4 squared. I should put in my unit. I have newtons. All right. So z is the square root of, what's that, 9 plus 16. Some number of newtons I'll pull out here. Z is square root of 25 is 5 newtons. There you go. All right, all good. Dang it. How do you get the angles? How do you get alpha? Oh, that looks like this right here. Looks like this right here, right? So some version of an inverse trig. You could do inverse sine, inverse cosine, or inverse tangent. Now, the one on the poster is inverse tangent. If you choose that one, you're looking at the 2 legs, right? So let's do that. Let's do alpha could be inverse tan of, so that would be y over x. So that's like 3 over 4 Newton, right? What is inverse tan? So it's second tan. It's inverse tan, also called arctan, right? 3 on 4. That's, I'm going to round this a little bit. 37 degrees. Hey, you guys saw some 37-degree angles yesterday because you guys saw some 3, 4, 5 triangles yesterday. Do all 3, 4, 5 triangles have a 37-degree angle in them? Sure do. Let's round it a little bit. You guys get beta? How can I get beta? You subtract this from 90 degrees. Will that work? And that would be what? 52 degrees, right? Or alternatively, what if you just change your reference angle and you also do an inverse tan and you just throw the legs the opposite way? What if you do this? Can I say beta is inverse tan of 4 on 3? Let's try it out. 4 on 3, so inverse tan that. Yeah, that's also 53 degrees. Look at there. Oh yeah, oh yeah. So multiple ways you can get to the answers. Right? Good. All right. Yeah, we have some time left in class. So just like I promised you guys at the top, if you finish this page, both sides, by the end of class, remember just 3 triangles on the front and all 10 puzzles on the back. You can pop it in this gray tray right here and you're good to go. If not, then due on Friday, and I'll walk around and help you guys out. Let's wrap up the recording right there.